Okay, guys, we're continuing on with Unit 3. We didn't quite get the lesson done. I would have had to rush through it. So we're continuing on from yesterday. So as you can see, we're going to be graphing inequalities down in A and B. Remember, we're going to be shading just like yesterday. The only difference is you can see in A and B, they have absolute values in them. And remember the absolute value form of an equation right here. We learned that last unit. The vertex, remember, is that point where the two lines connect, and that is HK. Remember that H is opposite because the minus sign in the formula before the H. Also, remember we treat A, the number after the equal sign, like the slope. Okay, so let's go ahead and graph. I'll do the first one in red. So we have y is less than 3. Remember, that's missing a variable. When it's y equals a number, it would normally be a horizontal line. Now, this guy, there is no underline for less than, so that would be a dashed line. So we put our point at 3, y-axis at 3, and then draw your dashed line. And the shading, less than, would be below. Okay, so the next one I'll do in green. We got an absolute value. Remember that will form a V. So the H is 1 because H is opposite. The K is 2. So we're going to put our vertex at 1, 2. Our slope here is an invisible 1. So that means we're going to form our V, we're going to go up 1, right 1. And up 1, left 1. Notice I drew solid lines because right here I have the underline. Now the shading, it's greater than, so that would be above. So above my graph. Now, we say that we have solutions in the extra dark shaded area. That's actually only a really, really small piece of it. Right in here, this triangle here is, if you look, it's just kind of in here, okay? So it's only part of the solid line here. Remember, if a point touches a solid line, that is okay. And then kind of below between the solid lines, but not touching that dotted line. Dotted lines do not count. So if I were to ask you, would the point 2, 1 be a solution? I would say yeah, because it's right here on the vertex, which is part of the solid line. What else? Would 0, 0 be a solution? Right here? No, it's not in the overlapping shaded area. Would 1, 3 be a solution? Would 1, 3 be a solution? Let's look where it is. 1, 3 would be right here. I would say that would be a no. 1, 3 is not a solution because it's on that dotted line, which does not count. Okay, moving on to the next problem. The first inequality, I want to get y by itself. So I'm going to subtract x. So now I'm going to graph it. So I have a y-intercept at 2. My slope is an invisible -1. So remember, that's going to be down 1 for every right 1. Down 1, right 1. Remember, I like lots of dots to make my line more accurate. I know it's tedious, but come on, it's only a few extra seconds. And then my sine is greater than, so that means I need to draw a dashed line. That is horrible. All right, with this stylus, that's about the best I can do. I was supposed to be going through all the dots, but oh well. It's tough. I can't use a ruler on an iPad. All right, and then for the shading, don't forget your shading. It is greater than, so that would be above the dashed line. Now I'm ready to move on to the second graph. I will do this guy in green. So the vertex, h is 0 because there's nothing in the absolute value. K is -4. So there's 0, -4. I got to draw my V. Now the A is an invisible 1. So it's going to be up 1 over 1. Both directions. And it's a greater than, so it's a dashed line. No underline is a dashed line. And the shading, it's a greater than, so that would be shading above the V. Okay, so you can see where they overlap, the pink and the green, or red, whatever you want to call it, overlaps. So all the solutions in there are, all the points in there are solutions. So if I were to go and ask you, okay, is the point 0, 0 a solution right here, this guy? No, absolutely not. What about 10, 10? Would that be a solution? Yeah, it's in the double shaded area, so we can say 10, 10 is a solution. What else? What about 4, 0 right here? Would 4, 0 be a solution? No. It's on that green line, but that green line is dotted, so that would not be a solution. What about 0, 2? Right here. Same reasoning, that would also be a no. It's on that dotted line. It would have to be strictly within this area here, but not touching the lines because they're dashed. Okay, next up, we're going to do some writing inequalities. The directions say, write the system of linear inequalities from the graph. So these are both straight lines here in A. So we're going to do y equals mx plus b. Pretty straightforward here. All right, red for the red. So that guy is, again, I'm looking at the kind of maroon reddish color. So I'm thinking y equals mx plus b, but no equal sign. I need a symbol. Now this, we got a dashed line shaded above, so that would be greater than. The slope, if we pick 2 points, that looks up 1 over 1, so we would call that a 1x or just x. And then the y-intercept right here is -2. And then for the blue, y is, I have a solid line here shaded below. So that's a less than or equal to. I picked 2 points for the slope, say here and here. That looks like it's up 1 over 3. So we'll say 1/3 x. And then the y-intercept is right here. That's at -1. Pretty simple stuff. You guys probably did this in Algebra 1. Okay, letter B, more practice. I'll do the red first. So again, they're straight lines. So think slope-intercept, y equals mx plus b. The red is a dashed shaded below, so that would be a less than. The slope, if we put a point here and say another here, that's up 2 over 1, which is 2x. And then the y-intercept is right here at 4, so plus 4. Now on to the blue. So we have a solid line shaded below, so that's less than or equal to. The slope, if we put a point here and here, that's up 1 over 2. So 1/2 x. Please make sure you attach an x to your slopes, people. And then your y-intercept is just 0. So if you want to put plus 0, go ahead, but really just, I would say, leave it blank. Just leave it right like that. Okay, next up says using algebra. That means using math, not graphing. That means numbers, operations. Using algebra, determine if the following points are solutions to the inequality. So what we have to do is test these out. Remember, points are x, ordered pairs x, y. So in order to be a solution to this system, it's got to work when we plug it in to both of them. So we're essentially doing 2 separate problems. So let's start with the first one. We're subbing in here. So 2 plus 2 times -2 is less than or equal to 4. Now we're going to simplify this. Do the multiply. And then subtract. Is that a true statement? Yeah, -2 is definitely less than 4. So that works out good. So far, so good. Now we must try out the second one. So we're plugging in here for the x and the y. So -2 equal to -2 minus 1. And then just subtract. -2 is greater than 3, so that works out also. They both work out. And when they both work out, we put yes. We would say yes, that point, 2, -2, is a solution to the system. Let's try the next one. Again, x and y for 2 and 2. So doing the first one here. So 2 plus 2 times 2 is less than or equal to 4. Multiply to get 2 plus 4. And then add to get 6. Now 6 is not less than 4. So we're going to put no here. We're going to stop. We do not care about the second inequality. If it does not work for one, it cannot work for the system. So we move on. And let's try letter C. Let's see if, let's test out negative 3, 1 and see if it's a solution. Again, this is called testing it algebraically. So x, y, using my first guy. So multiply, add. Negative 1 is less than 4, so far so good on that one. First one works out. Now we got to test out the second one. So now we're going to try this. So y. Now we have a negative in the formula, but then x is also negative. So that's a double negative. We'll change it to a positive in the next step. So 3 minus 1 will be 2. Is that statement true? 1 is not greater than 2. That does not work out. Remember, if 1 does not work, it doesn't matter. None work. We put a no and we move on. It's got to work for both of them. The only one that it worked was example A. Okay, example 6, using the graph, determine if the following points are solutions to the inequality. Well, I've been going through this the whole time, so this is just a little bit more practice. So we're just looking for, it says determine if they're solutions. That's just a yes or no answer. So in A, it's 2, negative 2. Let's see, 2, negative 2 would be right here. So that would be no. In order for it to be a solution, they actually overlap up here. And also they do work out on the solid lines, the part of the solid lines that touch that overlapping shaded area. So let's take a look. 2, 2, letter B, 2, 2. Zoom in here. 2, 2 would be here. Yep, that looks good to me. Definitely right there in the middle. So 2, 2 is going to be a yes. And then we got letter C, negative 3, 1. Negative 3, 1, that's actually over here. That's definitely a no. Okay, so I finished this lesson. Like I said, I wasn't able to finish it yesterday due to time constraints. So this one's a little shorter today. You'll be doing your homework with this.